test where we are comparing to see if two data sets are the same or if they are different. And again, reminding ourselves this is from our QDA data from our potato french fry test. And so we set up and we actually had Excel do the t-test, and now I'd like to just walk through and do some interpretation with you. So what on earth do all these numbers mean? Again, this is not a stats course, this is a chemistry course, but I want to walk through what the most important stuff is here. First thing we want to be looking at is this t-stat. This t-stat is reflected back into some statistical tables. And these tables, if we think about those bell curves that we were drawing before, we ask ourselves, in this aspect where it says two-tail, it means that we're asking the question, are these two samples the same or are they different? Whereas if we're asking about the one-tail test, we're asking, are they greater than one another? So is 2 greater than, or is 1 greater than 2? Whereas down here with the two-tail, we're saying, is 1 the same as 2? Hope that makes sense. So what we need to do in particular is look at this p-value here. So are we going to ask the question, is 1 greater than 2? Do the observers in 1 think they're seeing a darker sample than in number 2? Well, we're looking at this value here. And in general, we as a scientific community say that if it is less than 0.05, then we are confident to say they are different. So in this case, this is smaller than 0.05. 0.05, if I can use a very easy simplification, just means we're okay with putting up with a mistake 5% of the time, and that we're 95% confident. Well, in this case, we're 99.94% confident that we are seeing indeed that they are different. And the same with, or that, that 1 is greater than 2, and in this case, that they are different. Now, I did another analysis, and I did it against these two columns here, column 2 and column 3. And why? Because take a look at our mean, or our descriptive statistics here, 5.5 and 5.1. They're pretty close to each other, but just off of the surface, you could say, well, wait a second, these standard deviations are, they're small, but they're not insignificant. So over here we did a t-test, and take a look. Our p-value here is larger than this 0.05 value. And this, so we can say that 5.5 is not greater than 5.1. Same with this, they are not different from each other because this value here is greater than 0.05. Hope this makes sense. You're always welcome to reach out to me and ask questions, but this gives you some basics on doing some descriptive statistics on data sets for different types of chemical or sensory analysis in this class. Take care and have fun.